Hey, what's going on, guys? This is Moises Villagomez here to give you a video of the Nippon Sharyo trains. These trains originally came out, I believe, in the 1980s, in the late 80s. And now that we actually have this train here in this yard, I'd like to do a nice little comparison and contrast to the new Kinki Sharyo trains, which is pretty much the sister vehicle to the Nippon Sharyo trains, which came out in the 80s. And already, as you can see, there is quite a bit of a difference here. Everything is pretty much just analog. Here's your master control panel on this vehicle right here, and then you have your master control right there. It pretty much has all the same functions, regardless of whatever vehicle you're looking at. It's pretty much going to have all the braking points and power points that you're going to be finding on any vehicle. Just a different makeup, and you have your transfer key, your hazard lights, and all the other components that you need right here. And on this one, it is all a push button activation train to wayside TWC panel, where you could manipulate and control the tracks in the area that you're in. And then pretty much here is the entire controls for a train. That has your braking, your track braking anyways, and then your high horn, low horn, and sanding, directionals, doors, wipers, coupling, uncoupling, and also everything else that has to do with with your speed and the cab signals here. There you go. That's the first form of your IDU, your diagnostic table right there, your diagnostic board anyways. That right there, when lit, it'll be able to tell you exactly what your train is doing at the time. Right there's your speedometer, kind of lets you know what speed your train should be going, which is governed by your ATP, and your air gauge. Pretty much that will be your air gauge right there. That will let you know how much your reservoir tank and your braking tank is going to be holding at the time. And it goes up and down on applications as well, but we're not able to go inside this vehicle, being that no electronic devices will be done, which is why we're just doing a shot from the door, the entrance to the door. We're at the threshold, so I'm not able to go into detail as it, but this is just a nice little overview of what this vehicle looks like and how it operates back in 1980s. But what I really wanted to do here was to give you a little, I'll show you the difference between the interlocking doors here and how they look, and what are the main problems that these doors give you. And then what we see a lot here is, a lot of the times right there, some debris might get caught within that guiding rail or that guideline right there. So a lot of the times you just go in there and clear out what piece of debris, whatever. But for the most part, we do have like a lot of problems with these vehicles and having door issues, either component malfunctions or something gets jammed. So a lot of the times you'll probably get a door that won't close or a door that won't open. Regardless, this is where we step in. A technician will step in and diagnose this thing. From here, we will reach these items by inserting our barrel key. Once we put in our barrel key, it'll open up this latch here, and then you'll be able to have a better view of what you're dealing with. And this is what it looks like from the inside the vehicle. Everything's pretty much the same thing. You have your relays, your signal boards, and it's really basic. I mean, it's powered by air compression right here, and everything's pretty much labeled right here. It pretty much tell you what's going on. So in the case where the doors won't open or won't close, we pretty much just disengage the door by hitting this cutout valve right here, or you could call it a directional valve. It pretty much reduces all the air pressure to the doors itself, and it kind of lets you move the doors as needed. And from this point, we will take the door and manually close them, since we took out all the air, and we can now manipulate them as needed. Now that we took out all the air, pretty much just close these doors, and hopefully these stay there in place. And then there is a small lever here, the cutout lever. Now this lever is really basic. You push it down, and what it does, it closes the circuit, so the board down there will no longer have any control over it, and we can manually close this thing right here. And all this does is really just, it pushes a piece of steel up against the tab. I guess you would call it a locking tab, which is attached to the actual rail. This rail is what pretty much manipulates the entire door by moving up and down. It closes the doors up and down as needed, and by putting this panel down, it locks this tab in place and locks the entire rod in place, not being able to push or pull the door. And this right here, this is our emergency panel door. Say for whatever reason there is a fire, whatever have you, a fight, whatever happens, a customer can put their hand in there, pull this rod or this lever, and be able to exit. Of course, there'll be emergency going on, and then from there, they will be able to open up the doors and then release. But at this time, we're not doing that because within further inspection, it looks like, this has damage to it and needs to be replaced. It's only hanging on by a thread. This cable, it needs to be replaced immediately. Now this is just a regular inspection that needs to be done daily. I just wanted to give you a nice little overview of what the door actually looks like from the inner workings of it, and compare it to the new KI trains. But for most parts, whenever there's a problem on the main line, that's pretty much all you do is just cut out the air, lock it, and then, as you can see there, as you can see here, this pretty much puts our door out of service.